join me in welcoming Travis Egan.
Good afternoon. Good afternoon and welcome. Welcome to Hexagon Live Global 2025. Live from the iconic Fontainebleau Hotel here in Las Vegas, where ambition meets architecture and the future takes form. This week, we're not just at another event in the industry. We are stepping into a vision that we call Blueprint for Innovation. Over the next several days on this stage and in every room beyond these doors, we're going to be showcasing the people, the products, and the process technologies that are driving manufacturing forward. At my organization, AMT, the Association for Manufacturing Technology, our mission is clear, is to advance the innovation, the adoption, and the integration of manufacturing technologies that drive productivity, competitiveness, and long-term economic growth. We believe that technology is not just a tool, it's a catalyst. It's a catalyst for precision, for performance, and most importantly, for progress. So, whether you're building smarter production systems, deploying data-driven insights, or developing the next generation of skilled labor, AMT and Hexagon are aligned in our purpose. That is to elevate manufacturing as a modern, resilient, and essential force shaping the future. We're talking real-time data, next-generation automation, AI-powered precision, and bold thinkers like all of you that are turning these powerful tools into the next generation of transformations. From immersive keynotes to hands-on demos to visionary panels, you're going to see how Hexagon is not just making smarter solutions, but creating entire ecosystems that are driving industries forward. Now, this blueprint isn't theoretical, it's live, it's here, and it's made up of the collective intelligence, energy, and innovation from all of you, right here, right now. So whether you're a seasoned engineer, a digital disruptor, or a curious creator, this is your launch pad. Let's build relationships, let's build breakthroughs, let's build the blueprint for innovation together. Now, to take us deeper into this vision and to show how Hexagon is turning this blueprint into reality, I'd like to welcome to the stage a passionate leader, a champion for innovation. Ladies and gentlemen, President of Hexagon's Manufacturing Intelligence Division, Andreas Renulf.
Thank you, Travis, and hello, everyone. Great to be here with you. I hope you enjoy the conference so far, and there is plenty to come here. As I'm fairly new to manufacturing intelligence, I'll just make a brief introduction. So my name is Andreas Renulf, and I'm proud to be the new president of Hexagon's Manufacturing Intelligence Division. I spent a little bit more than 20 years in manufacturing, in technology, product management, engineering, from shop floor to global leadership. And outside of work, I'm a family man. I like to play the game of paddle, and I like to play the drums. Hexagon is committed to enable you as manufacturers to thrive. And for us, that's all about quality. Quality can mean many things to many people. And in manufacturing, many of us think of precision, accuracy, tolerances, or the outcomes of the good quality, efficiency, productivity, or profit. But quality is ultimately a simple thing, something that everybody understands on a human level. I grew up close to Gothenburg in Sweden, and that's where Volvo is trying to build the safest cars in the world. I don't know if you know that, but it was a Volvo engineer that invented the three-point seatbelt. And I spent 1 year working in assembling of seatbelts and airbags before studying at the university. And one of the mantras that we had in our assembly team was that no faulty seatbelt or airbag may end up in a Volvo. Sounds better in Swedish, but I think you get it. What I've seen since then, so quality was something that came to be very early in my career. And what I've seen is that the products that you produce, be it cars, airplanes, mobile phones, or life-saving medical devices, they touch people's life on a daily basis. And that's what we in Hexagon call quality for life. So let's watch a video so you can see how we see it.
Quality is a million things to manufacturers. It's just one thing to customers. A feeling. Quality is defined by touch, sense, or sound. It turns functionality into an experience. It's a sense of anticipation, a degree of excellence, something we appreciate instinctively. The products we make as manufacturers touch people's lives every day. Manufacturing innovation has shaped everything, from the way we live to the way we work. Life has never been better, but we can still push further. Within manufacturing, the way we talk about quality has to change. Quality isn't just micron-level detail. It's more than an industry standard for compliance. Quality is the #1 driver of innovation. The quality mindset powers huge leaps of progress, shaping better experiences, helping us to achieve more. Quality is the result of a business running at peak. It depends entirely on connectivity. Putting data to work drives continuous quality improvement across the value chain, unlocking multiplier gains at every stage. Quality accelerates when we bring together virtual and real worlds. With simulation, CAD/CAM, and metrology data working with AI in real time, manufacturers can feed insights back into design to accelerate innovation. Quality is for people. It's something we seek again and again. By adding the magic of quality to your products, you can truly move the needle for your business. Hexagon, for quality that touches people's lives.
So for us, quality is much more than a KPI. It's really our purpose. And our goal is to help you put quality at the heart of your operation, driving innovation and deliver quality of life for your customers. We recently did a survey of 2,500 companies, many of them current customers and some of them prospective new customers. And we asked how would they describe Hexagon. And as you can see here, there were two words that stood out. It's innovation and quality. They were the most common words. And the same survey also showed with a wide margin that quality is the most important criteria when selecting a business partner. I want to share a picture from a visit to our CMM factory, Coordinated Measurement Machine Factory in Rhode Island, Quonset Point. I was there roughly a month ago, and I was absolutely blown away by the accuracy of these machines. If you take a human hair and you enlarge it up on the right-hand side of this wall here on a 1x1 section, so the hair is from the bottom to the top, and then you take a pen and put a red dot there, that's the level of accuracy that we are talking about. And that level of detail, that's really the foundation of the measurement that then works for the quality. So our promise, as you have seen, when it has to be right, that's when quality matters. When you push the boundaries of known science, quality really matters. I want to introduce an organization that we're working with, and they are trying to create energy through nuclear fusion. It's a very, very ambitious project. So let's find out from ITER.
We need cleaner, more efficient, and more reliable energy than any other source. So we are creating a sun here on planet Earth by producing fusion reactions as a new energy source. But that requires the kind of conditions that you have in a star. It is a huge scientific challenge. A fusion reactor must be extremely precise. management, monitoring of the assembly is key to the success.
We're working with hundreds of meters down to a tenth of a millimeter.
It would be impossible to construct ITER without extremely precise metrology. So it is applied from the supply chain, from the manufacturing point of view, to the assembly, to the very end of the tokamak until the last element is actually inserted.
Hexagon is our preferred supplier for metrology equipment. With their great support and vast amount of capability, they supply pretty much all of the metrology equipment that we utilize on the site.
Clearly, we believe that we will see fusion energy being deployed around the world during this century. This will give access to the worldwide population to a better energy for the quality of their life.
Great ambition from the team at ITER. So we're very, very proud to support this truly international project. So it's clear that quality is critical, but quality can also be difficult. We are living in quite uncertain times and turbulent times, and in these times we have the headwinds to navigate. And to do that, manufacturers need to build agile processes. This week, we are releasing our second edition of our Advanced Manufacturing Report, and it's a research conducted by Forrester Consulting. We have gained insights from 1,000 manufacturing professionals globally, and the findings tells us some quite interesting things about how your peers view the industry today. So please download the copy. You can scan the QR code now if you want to. It should be big enough for you to aim there. So now let's talk about the findings. So given the climate, it's not that surprising that the top 5 business challenges all relate to agility. When it comes to other areas of the report, there are 85% saying that they are struggling to solve underlying root causes when it comes to quality. And this is an area that we want to attack. And I know this is tricky. In a former company I worked for, Trelleborg, which is a specialty polymer company, we used to have extremely tight tolerance windows towards the aerospace industry, sometimes actually overlapping tolerance windows by design. And we spent a lot of time with root cause analysis and fishbone diagrams and what have you. So this is a very, very tricky area. Another finding that stands out is that 97% feel limited by poor collaboration. And digitalization, which is widely seen as a solution to these challenges, there are still 91% telling us that they face barriers here on the digitalization side. If we summarize the report, the manufacturers face 3 key challenges, which is preventing them from delivering on quality. It's data, skills, and collaboration. And that's precisely where we in Hexagon have spent our product development focus in the last couple of years. So let's have a look at a few examples. Let's start with data. You could see earlier today from Burkhardt's presentation about the ATS 800. So every task and every job depends on a high degree of accuracy combined with speed and ease of measurement. One area which is very challenging are large volume applications like shipbuilding and aircraft assembly. And that's where our new Leica Absolute Tracker ATS 800 really excels. So it combines direct scanning from up to 40 meters with advanced feature detection, which is, we have not been able to do that in the past. So it's unheard of in the industry. And that together with highly accurate contactless measurements. So ATS 800 improves the productivity of inspection of large-scale space structures. So technology helps us to capture data, but we need skilled workers to handle the technology and operate the technology and use the data. So our industry has talked for many years about the skills gap, and that is something we continue to discuss. And we created digital tools to help with this problem. And one example is ProPlan AI. It helps ensure that you get assistance when you program production machining tools, but it also stays with the tribal knowledge that you have in your company. So you don't want to give away the data. So the AI is actually trained on your own data. Let's hear it from our customer Path.
We specialize in using ProPlan AI to focus on improving the skills of our existing operators, as well as capturing the tribal knowledge from our experienced setup machinists. With the introduction of ProPlan AI, we've actually doubled the amount of programmers on staff without having to hire from outside. With the changes in workforce available for CNC machining, ProPlan AI has been instrumental in allowing us to stay ahead of the curve and allowing us to produce more programs quickly without having to duplicate all those decades of experience. We've seen somewhere between 15 to 20% increase in production yield in the departments that have implemented ProPlan AI.
I've been working here since last October, and that's when I started using both ProPlan AI and Esprit Edge. The benefits of ProPlan AI for me is that it takes a lot of the monotonous clicks away. As someone that's new to CAM programming and Esprit Edge, I'd say ProPlan AI definitely helped me learn several different things about where to use which tools and that kind of thing. I think ProPlan AI has definitely had a positive impact in getting me to where I am today and gotten me up to speed as at least somewhat of a competitive programmer in 8 months.
So great example from Path, and thank you very much, Adrian and Gabe. Adrian and Gabe are here, so if you want to hear more about ProPlan AI, please feel free to contact them. One of the most incredible stats from our research this year is that 97% of manufacturers are limited by poor collaboration. And collaboration is much easier if you don't think of it as just a people problem, but also a technology problem. And finding that right balance between people and technology, that's really the trick. This is the idea behind our new autonomous metrology suite, which are cloud-native apps developed on Nexus. And they are designed to simplify programming and collaboration. It includes the Metrology Mentor, which is a co-pilot to automatically generate measurement programs from a CAD file, and also metrology reporting. It consolidates data from Hexagon and third-party systems to help you with the collaboration. So what we've seen the value of using the technology to address these challenges with data, skills, and collaboration. So let's see what happens when we put all of them together. And we have allowed ourselves the opportunity to ask if CMMs, coordinated measurement machines, had never been invented, how would we design them today? And our answer to that is Maestro. We have focused on 4 key areas: speed, ease of use, connectivity, and that it's future-proof. And we're incredibly excited about Maestro. We think it's a step change in the field of quality, but don't just take my word for it. Please head over to the zone and speak to someone there and let them demo it for you. It's pretty cool. Now let's shift gears literally and talk to someone else who also knows a great deal about quality and innovation. We will rearrange a little bit there, and after that we're back with Travis and a guest here.
So the RB17 is the car that never was. It seemed fitting, and the fact that there's so much Formula One DNA in it to make it that missing car. It sits with some illustrious stablemates in the lineage of Red Bull cars.
RB17 has been labelled as Adrian Newey's greatest hits.
It's basically Adrian Unleashed.
RB17 really is pushing the boundaries of everything we've learned into one car.
We're drawing on the real glory years of Formula One.
For me, a car at this level should also be a piece of art.
It's a big step up from anything that's out there.
It really is intended to be the last word in performance.
The aerodynamic performance is significantly higher than anything you can see. It's not possible with Formula One to do this level of aerodynamic performance.
Its downforce to drag ratio puts it up into aircraft territory, which has never been achieved before in motor racing.
It's going to be, I think, the most extreme track car of all time.
In manufacturing and in life, true excellence comes from getting it right, every time, with every detail. That's what builds trust, that's what delivers results. And now, nowhere is that more visible and more visceral than in the world of motorsports, where performance and precision collide at 200 miles per hour. And quality is not optional, it's everything. In a world where milliseconds matter, where champions are not just made by skill, but by discipline, data, and execution. I recently had the opportunity to meet NASCAR legend number 24, Jeff Gordon. And he shared this with me. He said, "It's not racing that I love to do, it's winning." And that quote says it all, because winning, real, repeatable, measurable winning, only happens when every part, when every process, and every person is developing at the highest level. That mindset is what we're bringing here to Hexagon Live, and that's the same mentality that you guys will bring to your own facilities, to your own factories, technologies, and teams. So now, let me welcome someone very special whose entire career has been shaped by innovation under pressure. From his early days trackside at Formula One to now leading cutting-edge engineering projects off the track, please welcome Technical Director for Red Bull Advanced Technologies, Rob Gray. Welcome, Rob.
Thank you.
Okay, so we're gonna have a little talk. So Rob, you've had a very interesting journey to getting to Red Bull Advanced Technologies with your career. And you kind of got like the best job, like the one percenter, the engineer that gets to work for F1. So if you could maybe talk a little bit about that journey that you took to get to Red Bull, and if you could, people might not understand the difference between Red Bull Racing and Red Bull Advanced Technologies.
Sure. So yeah, I mean the 1% thing is interesting because certainly when I was a kid, I always wanted to work designing race cars. I remember being asked by a cousin, "Do you want to be a driver?" And this was probably I was age 10 or 11, and my answer was no, I want to design the cars. And then you look at how you get into the industry, and it seems quite impenetrable because there was no really logical route in at the time. So I studied mechanical engineering at university, and then ended up doing things like Formula Student or Formula SAE, as you probably know over here, and then just found that doors started to open. And so Formula SAE led to a placement at a company called ProDrive, who built the rally cars. So my first real work was designing roll cages for Subaru rally cars. And then I think I was going to go and do a master's, and then I had basically decided to stay at ProDrive. And after that, ended up going into what was the Jaguar Formula One team. And once you're in, you're in. I said I was going to do Formula One for 3 years, and then I was going to get a proper job. I'm kind of still there.
It's a proper job.
Yeah, I guess so. And so as for the difference, so then within Formula One, I spent 18 years in various different roles, everything from structural analysis of the car, so making sure all the parts were strong enough, stiff enough. And when I started, there were 2 people doing that job on the whole car, whereas now there's probably a dozen. And you don't have more parts, you just have more triangles. And then all the way up to chief designer on the F1 car, so really being responsible for the car that was racing on a Sunday, responsible for when it went wrong, responsible for getting the performance onto it as quickly as possible. And then 4 years ago, I was asked, would I like to go and run what was then the Advanced Technologies division? It's now been spun out as a separate company. So what is Advanced Technologies, or RBAT, Red Bull Advanced Technologies? Well, it's basically us taking all of the Formula One knowledge, engineering, technology, processes, equipment, test rigs, the whole lot, everything we use to develop the race-winning Formula One cars, we take into Advanced Technologies, and then we use it in other sort of more real-world applications. some real world. Some are also looking at the Red Bull-esque stunts, whether that be hot air balloons flying over the countryside with BMX riders doing backflips, or America's Cup yacht racing, or KTM MotoGP. There's a huge variety. But it's closer to the real world than Formula One. And so that's what we do. And we offer it on both a sort of internal basis on projects such as the RB17, that I guess we'll come on to, but also on a consultancy basis to any company that really wants us to get involved.
So you mentioned the RB17, and that's an incredibly beautiful vehicle there behind us. So this is something different for Red Bull, and if you could give us a background on what this is and why Red Bull has gotten into making the RB17.
Sure. So I think it was mentioned in the video that it's the reason it's called the RB17 is it's the missing link. It was the car that didn't happen because of COVID, which was 2021, and so we took the chassis number for our own project. It's a two-seater, track-only hypercar that's really intended to take all of the learnings, everything we've learned in the last 20 years of Formula One, and distill it into the ultimate performance machine that we're then going to go and sell to 50 customers, and they can go and use on track, and the aim is that it'll be capable of Formula One levels of lap times. So to do that, we need a lot of power to drive the car forward, brakes to stop the car, obviously. We need to have lateral acceleration. So we have tires, we have very good tires that Michelin is developing, and we need to push those tires into the track with a lot of downforce. We need the car to be highly efficient, so we have minimum drag while we're developing that downforce. And then we need some active systems to keep the ride height of the car consistent so that the downforce can work or the aerodynamics can work in their best window at all times. And that means the suspension is correcting for things like the tires being squashed into the road. So that's the basics.
How much is one of those?
So it's in pounds, 5.75 million,
Okay.
plus taxes. We can put you down.
Well, it's not for me, but
Are we sold out at this point, or?
Almost. There's a small number left. Yeah. So I probably ought to mention what propels it forward, so power units. So we were talking earlier about the sort of the best, in my opinion, the best days of Formula One, which is the early 2000s, when we had V10 engines. So we've got a V10 engine in this car, 4.5 litres, revs to 15,000 RPM. So to make that happen, we have to have the air valve system that Formula One cars use. Currently, probably the thing that's keeping me awake at night is making that durable, but we'll get there. And then that's augmented with another couple of hundred horsepower of energy recovery system, so 1,200 horsepower overall. And the car only weighs 900 kilos, so it's a pretty impressive power-to-weight ratio.
So why is it called the RB17?
Well, because when COVID hit, we had to carry over the chassis of the previous F1 car to save money. So we carried that over for another year and had the RB16B, which was what Max won his first championship in. And then we jumped the following year to the RB18 so that we kept the relationship between chassis numbers and years the same. And then when we came to name this car, there was a chassis number that was free. So we'd actually started designing this car in the same year that we were racing the RB16B. So it felt like the perfect opportunity to take that number and fill the gap.
All right, so let's talk about quality. We've talked a bunch about quality. Andreas talked a lot about quality today. When it comes to the RB17, what does quality mean to you? And maybe what does quality mean versus a Formula One car?
Sure, so I think there's a couple of aspects to it, really. First of all, we've got to hit our functional targets. So I mentioned how the car's going to be Formula One fast. So to be Formula One fast, we have to have Formula One quality of components. So I'm talking about CMMs, measuring all of the precision components down to the last micron, and making sure we get that consistent quality, so all the cars are the same, and everything performs as it should. Then there's the reliability of the car, which is linked into that component side, the component quality side, because obviously we don't want these cars breaking down. They are going to last an awful lot longer and be more durable than a Formula One car. And then there's the sort of more perceived quality for the customer, where we need to have an absolutely outstanding level of finish, outstanding level of fit of every component, and everything the customer touches, and even actually everything that the customer won't normally touch, but the guys working on the car under the skin will touch, needs to have a really high level of perceived quality. So whether that be flawless paint finish, perfectly aligned carbon fiber weaves, high quality machine components with really good surface finishes. It all adds up to the quality proposition for the car.
Okay, so in a car like this, I would think you've got perhaps different challenges than perhaps you might have with F1. And what are those specific challenges, and how are you guys overcoming those challenges?
Yeah, sorry. So I was going to say on the difference in quality to Formula One. So I suppose the biggest difference is really the volume that we're producing, because while it's very closely related to a Formula One car, we're building 50 of them over a 2-year period, which is significantly more than we build in the Formula One world. And so that volume does mean that we need to have a bit. We're not going towards volume production, as in mass production. We're still building it in the way we know how to build race cars, but we are having to process an awful lot more components, and so the automated processing and automated CMM routines really come into it. In terms of the challenges of producing a car like this, the whole thing's a challenge. The biggest part of it that I think has really, you only really understand once you get too far into it to back out, is how everything on the car is absolutely on the limit. So we need all of the aerodynamic performance that we're planning to have. We need all of that engine power. We need everything to be working at 100% of its planned capability to deliver the performance that we're looking for. So that's one aspect. And linked to that is how tightly packaged everything is on the car. So there's not really a spare millimeter anywhere. So when we design every part of the car, we specify it. So take a wiring loom. We specify a wiring loom to connect, say, a fan that's cooling the engine. We design it down to we specify every number of copper strands in every cable. Then when you find that fan needs a bit more power, you have to actually then make that wiring loom bigger to go with that bigger fan. You also then find that the holes in the chassis and the routing of that loom have been optimized around the size of loom that we were working with. And so it becomes a bit like the butterfly effect, where we change something on the front wing, and before you know it, you have to change something on the rear crash structure as well, because it all just knocks onto everything else. They're my biggest challenges.
Okay, so it's good to have good partners when you've got big challenges. And Andreas, I'm going to pull you into the conversation here a little bit. This has got to be a long-time partnership between Red Bull and Hexagon, and there's no doubt that this team here is pretty ambitious. What's it like working with such a partner like Red Bull?
Yeah, I mean, this partnership has been going on since 2006, which I think is only 2 years after Red Bull formed its Formula One team there. For us, it's fantastic. I was up in Milton Keynes, where you have your site 3-4 weeks ago, and it's just an amazing site, and there are basically Hexagon equipment all over the place. I don't know how many Hexagon products you have up there.
No, I mean, somebody asked me this yesterday, and I don't actually have a number off the top of my head. I can count up that we have probably 5 or 6 different core areas that use the equipment with different particular inspection departments, but then the kit's also embedded in various different areas, so embedded within the car build area for when you're putting the cars together. We carry the kit on the race team, which before you know it means we have multiple sets that are different areas around the world. So yeah, I don't have numbers, but it's 10s and 20s of each type of equipment.
So I think for us, we have a partner here that have the absolute most demanding requirements when it comes to accuracy, but also especially to speed, the number of design changes, the fastness or the speed that has to work out with. I've heard a story, and I'm relatively new in this role, so I don't know if it's true. Maybe you know, Rob, but I understood that when we had our AT960 tracker as a prototype 12 years ago or something like that, it was given to Red Bull to test it out, but we just did not get it back until we had a proper product to replace it with there. I don't know if that's true, is it?
I don't remember the specific example, but if it is true, apologies.
It's fine.
I mean, it does sound like the kind of approach we would take, in that if, I suppose, the thing I've always loved about working in the race industry is that it's very single-minded. Winning, as Jeff Gordon says with your quote, winning is everything. And so if a partner has very kindly lent us a product that we're evaluating for a couple of weeks, I don't think we'd really worry too much about hanging on to it while it was helping us perform.
Right.
And I think, I'm sure from your side, you'd be probably more pleased that we're making good use of it and having success because of it than worrying about whether you wanted it back or not.
Sure. No, but it's really, it keeps us on our toes, and when we know that it works for Red Bull, then we know it's going to work in the rest of the manufacturing space. So it's very assuring.
So would you say this was pretty much of a game-changing product for you?
Yeah, well, I think it was when we were transitioning into setting the car up and using the tracker. So having targets on each of the corners of the car, rather than using the traditional sort of string and ruler methods. And it was really a speed thing, because Formula One, you're basically, on a Friday evening, you explode the car into a million pieces. There's everything you want to check. You want to make sure that all of your new parts are working as intended. You've got a whole schedule of parts that you're having to crack check and make sure they haven't deteriorated through the running. And so there's a lot of work to do. So anything you can do to take time out of that turnaround process, get that car back together sooner rather than later, and you have a curfew or when you have to be out of the circuit by a certain time. And so taking a few minutes out of that process really does make a difference, and means that you can go down to what's called the bridge, which is where the FIA have their measurement equipment. And back then they weren't using scanners, they were using manual templates. So you get the car set up, you go to the bridge, then you put the covers on and everyone gets to go home. And so, yeah, it was fairly game-changing from that perspective. But soon after starting to use it for setting the car up, we realized we could use it for an awful lot of other things. So if you had a problem with the car, rather than taking manual measurements to tell you what was wrong, what was out of position, what you'd find is that you could take a number of points using the scanner, and you'd get a picture of where the component was in space. And then that could be sent back to the factory, compared to CAD. And so rather than just being told the front wing's too low, we could actually understand, well, the front wing's too low, and we understand that it's coming outboard of this position here, which we call the FIA transition. And then you can start digging into why it's too low. So it became pretty integral to us fixing problems at the track as well as setting the car up.
So it sounds like it changed how you race, essentially.
Yeah, it moved the game forward.
Yeah. Well, you mentioned Jeff Gordon, and this conversation recently that we had with him, this came up, the same thing, where the influx of quality in racing in general, and in NASCAR as well, is really changing things and evolving how we race. So let's hear what Jeff had to say.
When I go to the start of my career in the 90s, yeah, there was times where I felt like, aerodynamics and technology wasn't playing near as big of a role, and it just felt like it was a little bit more old school type of racing. And so the driver's feel and the driver communication and how the mechanics could adjust to that played a huge role in a lot of victories. But rapidly I saw how that was changing in my career, and towards the end of my career, it was everything. It was just starting to deal in smaller increments and the details, and how important the technology, the simulation, the aerodynamics, the horsepower, everything started playing a role because competition started getting closer and closer. You're always trying to find an advantage, right? Try to find margins that get you ahead of your competitors. And now, those margins are just so small. I mean, we're searching for thousandths, hundredths of a second, thousandths of a second on the racetrack. When you're dealing with that much or that small of a margin and that kind of precision, you're now having to look at every aspect of the car because you want to stack those up in as many areas as possible. We're seeing that across the board in every area, from under the hood in the engine, from cooling, from aerodynamics, from tire modeling and air pressure in the tires, and every aspect of the car is now what's making the difference. Precision and accuracy, reliability, I think has never been more important than it is today in NASCAR.
So you hear from Jeff here how this technology-based shift really was a game changer for NASCAR. Would you say that's a similar experience for F1, or are you guys way ahead of that?
No, I think it's the same story. It's the same story.
All right, so it's clear that both Hendricks and Red Bull on the track benefited from this measurement technology. that Hexagon has supplied. How do you see that Hexagon is going to be fitting into the development of this RB17 vehicle?
Well, I think because RB17 is so closely related to a Formula One car, it's like under the skin, you can see so many parallels. We're very keen to use the Hexagon technology in exactly the same way as we use it in Formula One. So firstly on the component measurement side, secondly on the scanning side to see how all the bodywork fits and finishes are looking. And I saw the demo earlier today with the robot, and I love the idea of using a robot to inspect the car and look at, can the robot walk around the car and look at all the panel gaps and look at everything in one hit? And that to me feels like a real game changer. So yeah, we see it being absolutely integral to how we put these cars together.
I learned from you, I think, well, maybe yesterday we discussed, and you said that you actually, set the car up in Formula One for the driver so that it's really fit for that. Is that the same when it comes to this car? Is this set up for Max Verstappen or for a normal driver?
Well, the thing with this car is because of the active systems on the active aero and the active suspension, we actually have a lot of adaptability on the steering wheel and on the dashboard. Mm-hmm. So we can turn the car down. And so if you've got somebody who's not that experienced a driver, we can put them in the simulator to start with to get them used to the car. And then we can set the car up into a really nice, safe and friendly mode. So while it's a 1200 horsepower beast, we can actually turn everything down, put it into a mode where they're going to be able to drive it, they're going to be able to experience it, bias it more towards understeer, so it's a safe way of getting around the track. And then as they grow in their driving ability, they can then turn it up and they can really get the most out of the car. So we see it as a real enjoyable thing for a driver to use to develop themselves.
Okay. Cool. All right, so let's shift the conversation a little bit and talk about the skills gap. Andreas mentioned earlier in his presentation how the skills gap has created some challenges for manufacturing's growth. And I can't imagine that you have a lot of people that aren't lining up to work at Red Bull, but how has the skills gap affected your business?
Yeah, so I think on the manufacturing side, the skills gap isn't too big a challenge, and we do find it relatively easy to recruit, especially into the more junior roles. So we're tending to take on a lot of apprentices and grow our own talent. There are some areas, though, on the engineering side where we do really struggle. For example, finding electronics engineers at the moment seems to be particularly challenging. And I think that's because that side of the industry has grown exponentially with all of the, we're talking about robotics, for example, robotics, EVs, all of these industries require electrical engineers, and we're fighting with those guys now to get the talent.
So you mentioned EVs. Is this a gas or an electric vehicle?
This is a gas vehicle, but has a hybrid system. So there is a high voltage content. We sized the high voltage side of it really to be as small as possible, whilst being able to give you a bit of performance boost, but more importantly, be able to improve drivability, delete the reverse gear, delete the starter motor and delete the alternator. So it was, whilst there's a weight penalty for that hybrid system, we gain a lot of that back through the other systems that we've been able to delete on the car.
Okay, so if you could pick one key area of learning that you pulled from your experience at Formula One that you're going to bring to the RB17 project, what would that be?
I think it has to be the fact that as a company and as a group of people, we feel like we have a lot of confidence in our own abilities and we feel like we can deliver. So we tend to take things on that on the one hand feel slightly ridiculous, but history has shown that we tend to be able to deliver them. So at the moment, we're building our own F1 engine to race next season, which is a fairly big challenge. We're building the RB17, selling it to customers. It's a big challenge. And so I think it's that mindset that we've taken from Formula One more than anything, which is really if we put our minds to it, we can accomplish anything.
Okay, so we're here in Las Vegas, the gambling capital of the world. If you were a betting man, where would you be putting your money for F1 this year? Is Max going to have a chance, or are we going to shift all of our attention to the 2026 car?
I would never write Max off. We're only 10 races into the season. He is an absolutely fearsome competitor. So I'm not a gambling man, but if I was, I would still be putting my money on Max.
Excellent. Okay, well, thank you guys for a great little panel here. To sum things up, innovation isn't an accident. It's a discipline. And we heard from Andreas how quality is really creating a strategic advantage for many of their customers, and from you how this whole mindset around quality plays out not only on the track, but off the track with these new hypercar technology. So across both of these perspectives, for me, really three major things stand out. And that is first, that quality fuels innovation. Without great quality, there's not an opportunity to scale your business, and there's not an opportunity for these bold moves to become real-world advantages. Second, technology is only as powerful as the people that apply it. So you do have to have a great culture, you do have to have collaboration, and you have to have really talented people to be successful with quality. And third, innovation is not a one-time leap. It's a continuous process, one that needs to be measured, it needs to be refined over and over, and it needs to be informed by data and insights. So as we look forward to what's next, let's take this mindset with us. Rob, thank you very much for all your great insights. It's been fun chatting with you for the past few days. I can't wait to see the RB17 out on the track. And Andreas, I'll hand it over to you to close out the session.
Thank you very much.
Thank you. Thank you. Thank you. Thank you.
So thank you very much, Travis. Thank you, Rob. I think it's fantastic to hear from our valued partners in the motorsport area. We have Hendrick Motorsports, Oracle Red Bull Racing, and JDC Miller Motorsports today. When listening to their stories, it's very easy to see how the challenges that they work to overcome are to the scenarios that we as manufacturers face on a daily basis. And if you're a fan of Formula One, you probably heard the phrase "drive to survive." I think it's a great show. And we as manufacturers, we are looking for more. And as we discussed today, we are thinking about our drive to thrive. And motorsport teams, they work in a highly competitive environment. They are fully committed to succeed. And this, I believe, is the most important lesson that we can bring into our own operations. So, by placing quality at the heart of your operation, you can drive innovation, and you can deliver the quality of life for your customers. Thank you very much for listening. Enjoy the rest of the conference.